Okay, let's start reading about it. So this is a new question, problem number 167, and it's a medium mark problem. Looks good. It says 2 sum 2 input array sorted. Okay, so this is an extension of the 2 sum problem that we solved. What does the problem say? The problem says that given a one indexed array, so you have to assume that your array is one base indexed of integer numbers that is already sorted in non-decreasing order. What is the meaning of being sorted? Sorted means that they are arranged in some order. And which order they are arranged in? They are arranged in non-decreasing order. What is non-decreasing order? Increasing order or ascending order. So you can say the array is given in the form of ascending order. In the normal 2 sum problem, the question was not arranged in ascending order. If you see 2 sum, here there was no information that the array is sorted or ascending order arranged or not. Here you are definitely sure that the array will be arranged in ascending order. What is the meaning of one based indexing or one indexed array? That you have to assume for a moment that the counting of the array will be done one based. A lot of time you will find author of the problems doing this kind of stuff to just make problems a bit complex, but it doesn't make anything or it doesn't change anything in the logic. So don't worry. Okay, we'll talk about it. So you are having an ascending order array. You have to find two numbers such that they add up to a specific target number. So you need to find a pair such that they add up to the given target number. Okay, these numbers will be numbers at some index 1, number at some index 2, where both of the indexes should be different. Can you see what is the meaning of index 1 less than index 2? That means these two indexes should never be same, and it should be within the bounds of the array. That means you cannot pick the same element twice. So technically, it's the same question 2 sum. It's just written in a kind of like more detailed fashion. So you need to return the indexes of the two numbers added by 1 as an integer array of length 2. Okay, for example, can you see the same input 2, 7, 11, 15? Target is 9. This time the answer is 1, 2. Why 1, 2? Because you have to assume one based indexing. So if the answer previously was 0, 1, why it was 0, 1? Because the counting started from 0, then 1, then 2. Here the counting is starting from 1, then 2, then 3. So whatever is your answer, just add plus 1 to it. If you are able to solve it like this, just add plus 1 to it. Okay. The tests are generated such that there is only exact one solution, right? And you may not use the same element twice. This inequality represents that thing only. Your solution must use constant extra space. So that is good. So it looks like this is the same problem that we just solved a few moments back. Can I say that? It is the same 2 sum 2 problem. The only difference is the array is sorted. And you have to return one based answer. So how about if I copy the whole solution from here? If I copy my 2 sum solution from here and paste it here. And while returning, I just return I plus 1, j plus 1. Why you are returning I plus 1, j plus 1? To make one based indexing. One based indexing. Can I say that? By default, your array has 0 based indexing. So if you just return I comma j, it will be 0 based index. But if you do a plus 1, the whole array will become one based indexing. If you run this code, this will work. You can see. If you run this code, this will work. Okay, oh sorry, this should be numbers. Let's change nums here. Okay, let's change the variable name to nums. Okay. You can see it is working on the sample test cases. It looks good. But the question might come to your head that then why leetcode has one more same question with just a few changes in the language? Let's submit the code before we make that judgment. If we submit the code, can you see time limit exceeded? Ooh, why time limit exceeded? Because this time if you see the constraints, they are not 10 raised to the power 4. They are 3 into 10 raised to the power 4. Okay, they are 3 into 10 raised to the power 4, right? In this solution, if you remember, in this solution when we did the analysis, we were getting something like 2 into n minus 1, right? So if you do 2 into 3 into 10 raised to the power 4 multiplied by 3 into 10 raised to the power 4 minus 1. Can I say 3 into 10 raised to the power minus 1 is 3 into 10 raised to the power 4 only? So this becomes 2 into 3 into 10 raised to the power 4 into 3 into 10 raised to the power 4. Okay. Now this becomes what? 18 into 10 raised to the power 8. 3 into 3, 9, 9 into 2, 18, 18 into 10 raised to the power 8, which is what? Which is approximately 10 raised to the power 9. Yes or no? Because 18 when multiplied by 10 raised to the power 8 is going to give you what? 10 raised to the power 9. Approximately 10 raised to the power 9. But we were having only 1 second. In 1 second, you can only do approximately 10 raised to the power 8 instructions. But now you are doing approximately 10 raised to the power 9 instructions. That's why you are getting a time limit exceeded. So it's the same question. It is the same question, but you are going to get a time limit exceeded, right? This is where, again, what do we have to do? We have to think about an optimization. That can we optimize our solution a bit? So we are solving problem number 167. Okay. Now we have to think about some optimal solution. Can we optimize? This is what we have to think about. Make sense, guys? Make sense? Did you guys understand why TLE is coming and why I taught you all of that constraints, thing and everything? Do you guys understand it? Before I talk about the final solution, any questions? Any questions, guys? Okay. Yes, very good. A lot of you guys are on the right track. So, how about, let's say, you have an array like this. 1, 3, 4, 7, 11, 16, 22. Okay. And let's say the target is 15. Okay. Now we know that this is an array in ascending order always. What we can actually do is, instead of finding all possible pairs, we can find the pairs a bit smartly. How can we find a pair a bit smartly? Think about it like this. Can I say, if I take any two values, for example, 4 and 16, if I take any two values like 4 and 16, what is the sum of 4 and 16? 20. Can I say that? Now, if I take any two values like this ij, and their sum is what? 20. My target is 15. My target is 15. And 20 is greater than 15. That means I need to reduce the sum. Can I say that? I need to reduce the sum. Here 4 plus 16 is 20. I need to reduce the sum to actually make it close to 15. Can I say that? Now, how can I reduce the sum? I can very easily reduce the sum by moving j to the left. Can I say that? Or by maybe moving I to the left. Can I say that? So one intuition we are definitely getting that putting 2 pointers can actually help us. So let's start thinking in that direction. So what I'll do is, I'll put 2 pointers at the very ends. I equals to 0, j equals to n minus 1. Now, what is the sum of 1 and 22? 1 and 22 is 23. 1 and 22 is 23. Is 23 greater than 15? Yes. So I need to reduce the sum. I need to reduce the sum. Okay. Can I move I to the left? Can I move I to the left? No. There's no point. There's no position. Right? We cannot move I to the left. So the only way to reduce the sum is to move j to the left. Can I say that? We can move j to the left. Yes or no? Why we are able to move j to the left? We are able to move j to the left because of one more reason, which is if 22 plus 1 is greater than 15, then anything to the right of 1, if summed up with 22, will also be greater than 15. For example, 22 plus 3 will be also greater than 15. 22 plus 4, 22 plus 7, everything will be greater than 15. Can I say that? So if 22 is not compatible with 1, 22 is not compatible with anyone left. Can I say that? So 22 is of no use to us. We don't need 22. So what we do? We do j minus minus. Okay. 16 plus 1, 17. It is greater than 15. Again, we need to reduce the sum. We need to reduce the sum. Why? Because if 16 is not compatible with 1, 16 is not compatible with anything else also. Because 16 plus 3 is also greater than 15. 16 plus 4, 16 plus 7, 16 plus 11, everything is greater than 15. I do j minus minus. Now, 11 plus 1 is 12. This is less than 15. Now my sum is less than the target. If my sum is less than the target, I need to increase the sum. What are the ways to increase the sum? I can increase the sum by moving j to the right. But if you move j to the right, you will land up back at the same elements which are of no use to us. So no point of moving j to the right. Instead, move I to the right. Move I to the right. Now, 11 plus 3. 11 plus 3 is 14. 14 is less than 15. Again, the sum is less. I need to increase the sum of it. How do you increase the sum of it? You do I plus plus. And now, 11 plus 4 is 15. Is it equal to the target? Yes. We found our answer. So what we will say is, we'll say while, and we should do it again till the point both of them doesn't crosses each other, right? For example, let's say we didn't have 4 here. Let's say we didn't have 4 here, we had a 5 here. Let's say there was no 4, there was a 5. So when I came up here, 11 plus 5 is what? 16. 16 is greater than 15. Okay, 16 is greater than 15. So what do? You do j minus minus. Then 7 plus 5 is 12. 12 is less than 15. So what do? You do I plus plus. The moment both of them either points towards each other or crosses each other, you have to stop. You didn't find anything. Can I say that? Because if both of them points to the same element, you have completed all of the elements as of now. And the same element cannot be picked twice. So we can say while I is less than j. We will only go till I is less than j, not even equals to. Not even equals to. In the palindrome problem, in the reverse problem, even if we go to the equal to and try to swap the same value, it doesn't matter to us. But here, if we are on the same position, it will matter to us. Okay. So we'll say while I is less than j, I'll check if nums of I plus nums of j equal to the target. If yes, then you return I plus 1 j plus 1. Why? Because you need to return one based indexing. Can I say that? Else if the sum is greater than target, it was not equal to, it is greater than target, then you need to reduce the sum. How do you do that? You do j minus minus. If the sum is not equal to the target, if the sum is not greater than the target, that means the sum is less than the target. Then you do I plus plus. That's it. That's it, right? And that's how you can actually solve this problem. And now if you see how many iterations probably you went for, this is going to go for in every iteration. If you carefully see, in every iteration, we are eliminating one element. Can I say that? See, in the first iteration, I eliminated 22. In the second iteration, I eliminated 16. In the third iteration, I eliminated 1. So in every iteration, you are eliminating one element. Can I say that? In every iteration, you are eliminating one element. How many total elements are there? N elements. So how many eliminations you can make? N. That means how many iterations can be there? N. So total iterations is N. In every iteration, you are doing if checks and you are doing increments. So worst case will happen when you do all of the if checks and you do I plus plus. So approximately in every iteration, you are doing 3 to 4 instructions per iteration. So even if you do 4 instructions for n iterations, total instructions becomes 4n. And what's the worst value of n? N can be as big as 3 into 10 raised to the power 4. So 4 into 3 into 10 raised to the power 4 is 12 into 10 raised to the power 4. 12 into 10 raised to the power 4, which is approximately 10 raised to the power 5. And 10 raised to the power 5 is far, far, far less than 10 raised to the power 8, right? And that will actually solve the problem for you. Make sense, everyone? Make sense, guys? Okay. So if you try to code it, okay. So this solution gave us TLE, but very easily we'll be able to update the solution. How? We'll say let I equals to 0. So let's keep n. Let I equals to 0. Let j equals to n minus 1. While I is less than j, if nums of I plus nums of j is equal to the target, we return I plus 1 j plus 1. Again, why I plus 1 j plus 1? Because we have to move from 0 index to 1 based index. Okay. Else if the sum is greater than the target, then you do j minus minus. Else you do I plus plus. If you run the code, you can see sample test cases are working. If you submit this code, you can see the code has been accepted. Again, as I mentioned, you do not need to look at this runtime because currently it shows 60 milliseconds. If I submit it again, it is going to show another time. So let's wait. You can see now 63. So this time is of no use. I'll teach it in time and space complexity. But you can see we have solved our next problem, that is 2 sum 2, where input array is sorted. Okay. Manoj, we already solved the problem when the elements are not in sequence, right? There you can use that old solution, or you can